Hello, welcome to number 52 in our list of videos. Today we're going to be talking about computing the slope between points. There are two types of problems we're going to consider. We're going to consider computing slopes between points when we're given a graph and then when we're just given the coordinates. All right, let's go ahead and do this. So slope is the ratio between rise and run. That is the change in x divided by change in y. And that's what this symbol here is referring to. M is for slope. These two letters are the points we're finding slope between. Okay, so to find slope, we take a vertical step. It's a little bit hard for me to draw here. And a horizontal step. So I like to draw arrows to indicate how I went from one point to the other. We went up 4 here. 1, 2, 3, 4. And we went over 2. The rise is positive 4, the run is positive 2. The rise is positive because we went up. So rise is 4. Run is positive because we went to the right. 4 over 2 is equivalent to 2. So the slope between A and B is 2. All right, let's go from C to D. To go from C to D, we have to go down. And that's our vertical step, and then a horizontal step. So I'm going to draw little arrows. We could have went another way too. As long as you're careful about the signs of the rise and run, it doesn't matter. Okay, so we went down. So the change in y, which is the rise, is negative 2. And the run, we went 3 to the right. The run is positive 3. So the slope is negative 2/3 in between C and D. All right, E and F is a little funky. I'm going to start by going down here. So the rise is negative 4. But I see that I didn't run anywhere. I didn't go to the left or to the right at all. So the change in x is 0. E and F actually both have x coordinate 11. It didn't change. Now, this is kind of a problem. If you do negative 4 divided by 0 on your calculator, it says error because this is not even a number. So we can't divide it by 0. So these 2 points don't have a slope. It's said to be undefined. Okay, so it turns out that if points lie on a vertical line, they don't have a slope. Okay, any other time we can compute the slope. All right, this is kind of a similar problem. Sometimes we'll be given a shape in the plane, and we want to know the slopes of the sides. And we'll find out very soon why we would want to know that. But for now, we're just worried about computing the slope. So between A and B, we have to go down and then to the right. So we went down 5. 1, 2, 3, 4, 5. So the rise is negative 5, and the run is 2. So rise divided by run, negative 5/2. To go from, I don't see C and D. That's kind of a mess up here. So we're going to go from B to C. We'll call this from B to C. From B to C, I'm going to go to the right and then up the best I can. I have trouble going up. Okay, so to the right, that was 1, 2, 3, 4, 5, 6. The run was 6, and then I went up. The rise is 3. Rise divided by run would be 3 over 6, which is a half. Okay, finally, the slope of side AC between the points A and C. So I'm going to go to the right, and then I'm going to go down. So I went this way. That's the run. 1, 2, 3, 4, 5, 6, 7, 8. X changed by 8. And this is the rise. I went down, so it's negative. So that's negative 2. So rise divided by run is negative 2 over 8, which reduces to negative 1/4. So we got to get in the habit of reducing these. This was 1/2. And this was negative 5/2. Okay, fine. Now, everything's great, but sometimes you got to be a little careful. So, of course, math always gets a little tricky. We've got to watch the scales here. These, on the x-axis, this is going up by 2. And on the y-axis, these aren't going up by 1 anymore. They're going up by 5s. So we have to be a little careful when we find the slope, right? The slope between P and Q. Let's go down and then to the right. Okay, so we went down 2 squares, but each square counts as 5. We went from 35 down to 25. So the rise is negative 10. And then on the x-axis, we went 1, 2, 3, 4, 5 squares, but each count is 2. So that counts as plus 10. Right? 2, 4, 6, 8, 10, going that way. Okay, so our rise is negative 10, and our run is positive 10. Negative 10 divided by 10 is negative 1. we have to be careful and watch the slope, or watch the scale. All right, from R to S, I'm going to take a vertical step. I'm going to go up, and then I'm going to go over. Okay, we went from 5 up to 15. That's positive 10 for the rise. We went from 2 up to 8. That's plus 6 for the run. So rise over run would be 10/6, which is 5/3. So if there's different scale, you just got to pay attention. Think how much you're going up by in each direction, or just look how much X and Y changes. All right, we're getting there. Now, we don't even need a graph at all, to be honest. We can just look at the coordinates of the points and figure out rise and run. So in this first one, the rise is how much Y changed. Remember, Y has to do with Y. This little triangle symbol means to change in Y. Well, Y started at 7, it went down to 5. So the change in Y is -2. So we looked at the Y coordinates. Then it started at 10 and it went up to 16. The run was 6. The X changed by 6. So without even having the graph, we can figure out how much they changed and compute the slope. All right, on this one, the rise, that's the Y's, started at 42, went down to 32. It went down by 10. And then the X's started at 3, went up to 18. That went up by 15. So the rise is -10. That's a change in Y. And the change in X, I'll put it over here. The change in X is the run. That's 15. So that'd be -2/3. Now, that's a little confusing. All right, what were you doing here? I was just computing the change in the Y and the change in the X. Now, you don't have to do it that way. There's a cool formula for this. And this is our last slide before the assignment. So here, I'm sure you've seen this before. This is the formula for slope. Okay, so we got to subtract the Y coordinates on top, and the bottom we subtract the X coordinates. X1 and Y1 refer to the coordinates of the first point. So this first point, we have X1, Y1, and X2 and Y2 tell me that those coordinates came from the second point. Okay, so now we just follow along. To compute the slope, we got to do Y2 minus Y1 divided by X2 minus X1. When we subtract the coordinates like this, we're finding the change. So 9 minus 6 is 3. 4 minus a -3. Gotta be careful. It's not 4 minus 3, it's 4 minus a -3. That's 7, and that can't be reduced. Right over here. Okay, this is X1, Y1, X2, Y2. Subtract the Y coordinates on top, just the way they are. Subtract the X coordinates on the bottom. We gotta do kind of the same order. And so we get -12 over 9, which is -4/3 if you reduce it. All right, last one. So see, using the formula, this will be really automatic after a while. So this is coordinates of the first point, coordinates of the second point. Subtract the Y's to find the rise. Subtract the X's to find the run. I get 5 over 0, and I recognize that, oh, this is a problem. Can't have 0 in the denominator, so this one was simply undefined. These 2 points, they don't have a slope. Right. Wow, that was a lot of slope really quickly, but I know this is old news for you guys. And I think you'll do fine on the journal assignment here. So you have 2 problems. On the first problem, just compute the slopes of the sides of the triangle. We got PQ, RQ, and PR. Those are the 3 sides of the triangle. Then, for problem number 2, just use the formula to compute the slope between these 2 points. The formula is here on the side. All right, I think you guys got this. I'll talk to you later.